So in the previous videos, I've talked to you about the fact that fossils are a particular age, but how did we determine that age? And there are two methods that we need to know. The first one is called relative dating, and it's not dating your sister or your brother or your cousin. Yeah, it's about determining how old something is in relation to another thing. And then the other type of fossilization or dating method that we're going to talk about is the absolute dating. So that's an entirely different video. It's going to be a lot longer, and we're going to investigate these things called half-lives. But let's have a look at the first method. And the first method of dating a fossil, so determining how old it is called relative dating. So you've probably done this in a bit of a problem-solving way before. Essentially, you can find rocks, particularly sedimentary rocks, that have lots and lots of different layers to them. What you can do is you can identify that certain parts are the same in different regions. And we can go, okay, that's all about the same age. It means that anything lower than that point is going to be older than that layer. Anything above that point, anything higher up, is going to be younger. And that's all we can determine with relative dating. So you can look at the layers, and what we call that is we actually call it this bottom bit, we call it stratification. So sometimes you'll see questions talking about relative dating, and you can say they use the process called stratification. So this is using the strata of the rocks. So these layers here, sorry guys, these layers here, the layers, and it's not working for you, is it? Let's just go a bit forward, back. No, there we go. These layers are called strata. So using the layers and deciding whether or not something is below or something is above can tell us how old it is in terms of relative to that level. So the stratification is the process. We use it to compare how young and how old these things are. And I'll go through an example with you in just one second. But we are on page 9. Page 9 at the moment in your book. And there's a little bit on stratification. And you can add in there that anything that is higher than a particular level, we consider to be younger. Anything that is lower down, we consider that to be older. The other thing is using an index fossil. So what we can do is we can actually use a fossil within this. I might come back to that in just one second. So what I might get you to do, or what this task might ask you to do, is determine what the oldest fossil is and what the youngest fossil is. So the oldest is always going to be as far down as you can get. So the oldest in this case is going to be A because it's down the bottom. Then it's going to go B, C, funnily enough, up to D is the youngest. So that's the order we can do. You can see that in this location here, you won't find any particular layer, you won't find any layer B. In this one here, you don't have any B, C. So in location 3, you don't have any B, C, or D, so on and so forth. But what we can do is we can now show you what I mean by index fossils. So an index fossil in this case might be this guy here. So you can see that he only exists in this layer. Index fossil. He only exists in this layer. And as a result, you can actually see that he exists over a wide geographic area. And you can use him as a comparison. So if you see something that's buried below that ammonite, then you might go, okay, that must be older. If I see something that's buried above that ammonite, I must go, okay, that's going to be a younger fossil. So that's a really good index fossil. You might see on here, can you pick any bad index fossils on here? An organism you don't want to use as an index fossil. So hopefully you've come back. I wouldn't want to use this guy because he exists in 3 different layers. So all you can tell is if something was really, really old. You can't tell if something was younger. You can't tell if something was older than that. Well, you can tell if it's really, really old, but you can't tell a lot. So index fossils are really good because they exist for a short period of time. We know when that time was, and we can then use that to compare others. Another bad index fossil would be this little moth guy. You can see that he exists, although he exists over a wide geographic distribution because he's in all the sites, he was there for too long. So they're not good. You need something that was there for a short period of time. And a wide geographic distribution. There is one other fossil on here that might be a good index fossil. That might be this trilobite down here. You can see that he only existed in the bottom layer, and he existed across a wide geographic distribution across all sites. So you would know anything that is above him is going to be younger than him, and anything that is below him is going to be older than him. Here, example again, having a look at where our oldest layers are. This might be done with color. It's not going to be done with colors. It might be done with patterns. So you might go that this guy down here, this, hang on, let me just put it on black. This layer is the oldest. And you can see as you go up, it doesn't matter that there's no D here. There must have been some kind of earth event that's shifted those out of the way. But it doesn't matter where you are. This layer will have similar fossils to this layer. And so on and so forth. So you can see that this guy up here, this layer L, is going to be the youngest layer here too. And if you find a fossil in that layer, you can determine that it was younger and it existed a lot more recently compared to the previous ones. And hopefully that's a little bit of a summary on what is relative dating.